All right. So these, like I've mentioned in some previous videos or future videos, depending on what order you watch these in, one of the more difficult parts of this is understanding what they're actually solving or what they're asking you for, even though they're pretty explicit in that, because we're kind of lumping these application questions together. Some of them are about velocity and about speed. Some of them are about arc length. Okay. This problem in particular, first glance, it talks about the minute hand of a clock, and when you think clock, you associate clock with time, and time with distance and speed, right? So first glance, you look at this and you say to yourself, this is probably a question about velocity because it's talking about a clock and moving from 12 to 10 o'clock. But when you read the whole thing, the minute hand of a clock is 12 inches long and moves from 12 o'clock to 10 o'clock. Okay, so let's set this up. Here's the minute hand, okay? And I'm going to leave that there as the quote unquote initial point of this angle. It moves from 12 o'clock all the way around to 10 o'clock, which we'll put right here, okay? So forget the crude drawing. Why don't I try this? Let's see if this will work. There you go, from 12 o'clock to 10 o'clock. So this object, the tip of the minute hand, how far does the tip of the minute hand move? It moves from 12, right, to 10 through this arc length. So they want to know how far did the tip of that move. That means it's complete distance away from the center, which is 12 inches, rotated through this arc length. Okay, so this is an arc length question. It's not dealing with velocity. And arc length can be found, excuse me, by multiplying the length of the radius times the central angle that this object rotates through. So this central angle rotated this far, right? It rotated, for lack of a better word, 10/12ths of the way around the circle. So this has to be in radians, right? So the angle that this passed through is 10/12ths of 2 pi radians, right? So if it was 12/12ths, that would be one full rotation. That would be 2 pi radians, right? But it's not. It only went through 10 of the 12 pieces, if you will, right? Every number on the clock represents 1/12th of the circumference, okay? So we still have 11 in here somewhere. So 10/12ths of 2 pi is 20 pi over 12, which is, what do we get here? 5 pi over 3. Does that sound about right? I think so. Hold on. Why isn't my brain working properly? 5 pi over 3. Yeah, I think that's right. Forgive me if it's not. So this is the measure of this central angle, 5 pi over 3, that this minute hand passes through. So the arc length is the radius, 12 inches, times the length, or times the radian measurement of that central angle, which ends up being 20 pi inches, right? So arc length is radius times radian measurement of the central angle. Radius times the radian measure of the central angle is 20 pi inches. And in terms of pi, that would be our answer. In terms of 2 decimal places, I'll let you guys figure that out. 62.8 something something. Okay, you can figure that out on the calculator. But bottom line is, we're finding arc length. We're using this formula, and we had to figure out what that angle was in radians to start. And we typically leave our radians in terms of pi when we do this calculation. All right.